Yeah. Okay, if you are new to this channel, please try to subscribe, like, and share. I I want to share with us the inverse of a function using first principle. That is differentiation using first principles. We are differentiating inverse of a function like this. In the first place, what I want you to know is that assuming you are given tan y equals to 0.3. Now normal mathematics. So we are going to divide both sides by tan all over tan cancel tan, that is y equals to arctan or shift tan 0.3. Now the same method applicable to this. That means this one will become x equals to tan y. That's the first thing, because it is going to equal to s equals to tan y by the virtue of what you are seeing here. Because tan y, so I later brought, this one came to come and meet it here. That's why I carry arc tan. So, but by the time, because actually this tan was coming from here, so it was coming from here, and the x was standing alone. That's what I just explained. Now let us continue. We want to differentiate it using first principle. You know that our first method is changing x plus dx equals to tan y plus dy. X plus dx equals to tan y plus dy. So the next steps to take is that we make the s the subject of formula. So the x equals to tan open bracket y plus dy minus x. We are making the s the subject of formula. Okay? After that, the x equals to tan y plus dy minus, and what is our x? What's our x originally? Our x is tan y. Our x is tan y. Now, to continue with, the x equals to, what's our tan? Don't forget that our tan equals to sine all over cos. You see that one in one of our previous videos we've made. Tan is sine all over cos. That means sine open bracket y plus dy all over cos open bracket y plus dy. This equals to this minus tan, that is sine y all over cos y. After that, we'll find the LCM. And our LCM is cos open bracket y plus dy cos y. That's our LCM. If this cancels this cancels this, we are going to be left with sine y plus dy cos y minus this cancels this. So we are going to be left with sine y is equal to cos y plus dy. Y plus dy. Now, if you don't forget the x equals to everything. If you could check very well, that is, if you don't forget that sine a minus b give us sine a cos b minus cos a sine b. That is exactly what we are seeing here. Let me show us that I'm saying the truth. Sine this, y plus y represent our a, cos b represent our cos y, minus cos a represent our this, and sine b represent our this. With a minus, that means this is actually talking about this, which is sine a minus b. Okay, that means I can just say sine, my here should be y plus dy, y plus dy minus this y, this bracket, all over cos y plus dy, this bracket cos y. Very simple. So we continue. by saying dx, don't forget, our dx equals to, this cancel this, that means sine the y all over cos, open bracket, y plus the y, close bracket, cos y. After that, what to do now? We want to divide both sides by the y. So this is dx already, all over dy, and divided by dy over 1. And after that, what do we do? That means the x dy equals to sine dy all over cos y plus dy cos y multiplied by the division, we change to multiplications. 1 will go up, dy will come down. 1 all over dy. Now see what I want to do now. So I want to do, I will just say, okay, dx, sorry, this one is dx. Dx all over dy equals, I'll just say sine dy all over, I brought dy here, multiplied by 1 all over everything you see here, which is a cos, open bracket, y plus dy, close bracket, cos y, as you can see. Now the next thing to do from here is that the x dy, don't forget that this equals to 1 under our standard limit. When you see sine dy all over dy, I told you in our previous video, when they are equal like this, equals to 1. That means equals to 1 times 1 all over cos y plus dy cos y. After that, our dy tends to 0. Our dy tends to 0. That means the x dy equals to 1 all over cos, open bracket, y plus 0 cos y. That means the x dy equals to 1 all over cos y plus 0 y times cos y. So that means the x dy or the x dy equals to 1 all over cos square y. Now, when we get cos square y, from our trig identities, if you could remember, in our trig identities, I say h square equals to o square plus a square. When we divide through by a square, all over a square, all over a square, all over a square, h over a, a all over h is cap, while h all over a is sec. O all over a, that is tan square theta plus 1. That means sec square theta equals to tan square theta plus 1. The same thing I will apply here. I'll say the x dy equals to 1 all over 1 plus tan square theta, tan square y. This equals to this. The x dy equals to 1 all over 1 plus, from our initial distance, our x equals to tan x equals to tan y. You remember. So that means 1 plus, you can say 1 plus x squared. It's also the same thing as also 1 all over 1 plus tan square y. So that is our answer for the inverse of the function. Thank you.